this example, we're going to find the area of the region enclosed by the following two curves. Y is equal to x squared, and y is equal to the square root of x. The first thing that we're going to do is we're going to find the points where these two curves intersect. So we're going to start by setting them equal to each other. This gives us x squared is equal to the square root of x. To solve this, we are going to square both sides, and this gives us x to the fourth is equal to x. Now we have to be really careful not to just cancel out an x, because we're going to lose a root if we do that. And we need to rewrite this as x to the fourth minus x is equal to 0. We can pull out an x, and then we have x cubed minus 1 is equal to 0. And this gives us x is equal to 0, and then x cubed is equal to 1, and this gives us x is equal to 1. So let's just write down here that we have x is equal to 0 and x is equal to 1. Now let's find the y value. We can use either curve. I'm just going to use y is equal to x squared. So when x is equal to 0, y is equal to 0. And we have the point 0, 0. And then when x is equal to 1, y is also equal to 1, and we have the point 1, 1. Let's highlight these because we are going to need these when we graph our region. And that's exactly what we're going to do now. Let's begin by plotting our two intersection points, 0, 0. And let's go ahead and let's make 1, 1 right up here. Give us a little bit more space. Let's hold off labeling the graphs and go ahead and graph our two curves. Our two curves are y is equal to x squared and y is equal to the square root of x. Y is equal to x squared looks like this. And then y is equal to the square root of x looks like that. So the region between these two curves is this region right there. Now let's go ahead and let's label everything. Our first intersection point was the origin, 0, 0, and then this point was 1, 1. Our curve in blue is y is equal to x squared, and then our other curve is y is equal to the square root of x. It's really important to label everything because that's going to make setting up the integral a lot easier. Now we have to choose a formula for our area. We have to choose if we want to integrate with respect to x or respect to y. If we integrate with respect to x, we need one curve on the top and one curve on the bottom. If we draw a straight line here, we can see that we do have a curve on the top and a curve on the bottom. Now let's see if we can integrate with respect to y. If we integrate with respect to y, we need a curve on the right and a curve on the left. And we have that as well. With this problem, we can choose to integrate with respect to x or with respect to y. I am going to choose to integrate with respect to x because our two curves were written as y is a function of x. Let's write down our formula. Our formula is the area is the integral from a to b of the curve on the top minus the curve on the bottom times dx. Our curve on the top is y is equal to root x, and then our curve on the bottom is y is equal to x squared. Now let's go ahead and let's evaluate our integral. A is equal to the integral from 0 to 1. The curve on the top, which is root x, minus the curve on the bottom, which is x squared times dx. One thing that's really nice with these problems is if you do make a mistake and you pick the wrong curve for the top and the wrong curve for the bottom, what's going to happen is you're going to get a negative area. And if that ever happens, just know that you just go back up and switch the curves. Let's go ahead and write this as the integral from 0 to 1, x to the 1/2 minus x squared times dx. Our integral is then x to the 3/2, all divided by 3/2, minus x cubed divided by 3, and we're evaluating that between 0 and 1. We can rewrite this as 2/3 x to the 3/2 minus 1/3 x cubed, and we're going from 0 to 1. This gives us 2/3 times 1 to the 3/2 minus 1/3 times 1 cubed, and then we subtract 0, and that's always nice. This then is equal to 2/3 minus 1/3, and we get a value of 1/3. The area of the region enclosed by these two curves is equal to 1/3. I want to show you one more thing before we're done. One thing that you can do is you can draw a box like this, and you know that the area of that box is equal to 1 because each side is 1. So it makes sense that our answer is 1/3.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.